I wanted to finish out the week by looking at some applications because obviously we try to look at applications as much as we can. Why are we learning the math that we learn? So let's take a look at some applications together. So these questions hopefully will be sort of a culmination of everything we've learned last week and this week. First question and second question both have to do with the basic structure of an exponential growth function. So first, we have a car purchased for $24,000. It's depreciating, so it's losing value at 8% per year. We want to do two things. We want to first write a model for V of t that gives the value of the car for t years after the car was purchased. And then two, how much will the car be worth 4 years after it was purchased? So two questions. Again, just as a reminder, again, we've talked about this before, but a reminder would be that c in this function represents the initial value, r represents the rate as a decimal, and t represents the number of years. So if I'm doing question 1, the model asks me to use v of t instead of f of t, so v of t for value based on time. The initial value, c, would be 24,000. That's how much it started out being worth. Because it's depreciating, it's losing value, so I'm going to take 1 minus 0.08 because that is 8% as a decimal. And I'm going to take that to the t. And again, don't plug in 4. That's what a lot of people do. They make that mistake. 4 happens in question 2. So question 1, my final answer would just be v of t equals 24,000. That would be 0.92 to the t. Now, what's the significance of 0.92? That means each year the car loses 8% of the value, but it retains 92% of the value. That's why we're taking it times 0.92 to the t. Question 2, the second part of question 1 says, what's the value 4 years after the car was purchased? So that means I'm plugging in 4 for t because t represents the number of years since the car was purchased. So 24,000, 0.92 to the 4. Use my handy dandy calculator, and I end up with 17,193.43. Again, this is a dollar value, so it makes sense to stop at cents. Second question, again, two parts, same idea. I'm going to first write the model using v of t. I started at 1.43. It's appreciating or increasing in value, so 1 plus 0.05 to the t, which means my model for the first part of this question looks exactly like this. It's important that you write it with t because it says write the model. The second part of this question says now find out what happens after 10 years. So now I'm just going to find v of 10. So 1.43 times 1.05 to the 10. Again, just utilize your calculator directly from there, and I get 2.33. And again, I'm going to round to the nearest cent because it makes sense in the context of the problem. This one's a little bit easier than the last one. This one's saying, hey, do you know all the parts of an exponential growth or decay function? So find the initial temperature. If c of t represents temperature of a deli sandwich, this guy is the initial value. So the initial temperature must be 19 degrees Celsius. Does the model represent exponential growth or decay? Well, remember this guy is 1 plus or minus the rate. So if this guy is less than 1, then this must have been subtracting a rate of 3%, 0.03, which means it must be exponential decay. It's decreasing in value each year, or in this case each t, which is minute. Final question, by what percent does the temperature change each minute? I kind of gave that one away when I did this part. It's 3% because I would have had to take 1 minus 0.03 to get 0.97. and therefore it must have been a rate of 3%. So a 3% decrease each minute. So here's kind of a silly question. It seems complicated, but it's really not. What we're going to do is it's talking about the energy E released as an earthquake of magnitude M. And then they give us the 7.0 magnitude earthquake that hit Haiti in 2010. So what we're going to do is we're just going to take our original equation, and I'm going to plug in what I know. And the only thing I know is that the magnitude of the earthquake was a 7.0. So easy enough so far, right? Log base E 15.32. And that's adding both values together. So I could have broken this down further, said 5.24 plus 1.44 times 7, which was 10.08. And again, notice I'm not going to round anything, but this gives me 15.32. So what do I do from here? I'm trying to solve for E, and I've got a log function, so all I have to do is know how to solve a log function, and we've practiced the crap out of that. This is base 10 because there's no base, so I'm just going to swirl it, which means 10 to the 15.32 is equal to E. Well, that made it really super stinking easy. So 10 to the 15.32 gives me 2.08929, and then I have E15. So have you ever wondered what that meant? What does it mean when I get E15? What this means is this decimal place has to go 15 places in the positive direction. So I'm going to get 208, so that's moving it 2 places. 929, that's 5 places. 6, 7, 8, 9 places. So 10, 11, 12, 13, 14, 15-ish. Obviously this is an estimation. So I can look at this as my answer. So this is written in scientific notation. It essentially means 2.08929 times 10 to the 15th. That's what that E15 means, is basically that you've got an exponent, you're dealing with scientific notation. So basically a lot of joules of energy were released at that particular earthquake. You are most certainly going to get questions like this one and the next one, so pay attention. Again, it's just solving an exponential equation, so we should be really good at that. And it's using that A equals PE to the RT function or formula. That is my compounded continuously formula that we practiced a lot last week. So let's take a look at how we would use that to solve for some unknown. So we have $10,000 invested in an account, earning 4.5% interest. I'm going to go ahead and rewrite that right away. Compounded continuously, that's how I know to use this function. Determine how long it will take. So if I'm asking how long it will take, that tells me I have to solve for t to grow to 25,000. So what I have to do is I have to take this function and I have to plug in what I know. So that's the question. What's 10,000? Well, it says 10,000 is invested, so 10,000 is P. E is always E. Don't try to replace E with anything else. My rate is 0.045. And it says how long will it take? Well, that means T should remain T because I have to solve for that, which means what am I missing? I'm missing A. A is the accumulated amount. We're saying how long will it take to accumulate to a total of 25,000. So hopefully the good news is once you get it to this point, this should be easy because we have done this over and over and over, and I believe it was our last video, solving 2 videos ago, solving exponential equations. So how do I solve this? Well, the first thing I want to do is get this part of the function by itself. So I'm going to divide each side by 10,000. When I take 25,000 divided by 10,000, because it turns into a nice decimal, I'm going to go ahead and go with the decimal. The only time I wouldn't do that is if I had something that when I divided, it turned into an ugly decimal, like 1.3792, etc. Then you keep it as a fraction till the end. So I have 2.5 equals e to the 0.045t. Now what? Well, I've got e. E can be undone by the natural log function. So the natural log of 2.5 equals the natural log of e to the 0.045t. Natural log of 2.5 is an ugly decimal, so I'm leaving it like this for now. Remember, we don't do any work until we get to the end. This side, natural log and e sort of go away because they're inverses, so I get 0.045t. Now I'm going to divide each side by 0.045, and I get t equals, this is my exact answer. Now, do I want the exact answer? No, because I want to really find out about how many years and round to the nearest year. But it's important that I don't do rounding in the meantime, so that's why I kept it precise till I got to the very end, and now I plug it into my calculator, and t is approximately 20.362. So the question is, about how long will it take for me to have $25,000 in the bank? So some people would say it would take about 20 years, and I'm okay with that answer. But a lot of people are a little more precise and say, well, okay, Professor Brain, but technically at 20 years, you don't have 25,000 yet. So if you want to round up and say at 21 years, you would have 25,000 in the bank. I mean, obviously you'd have more than that, but you get the idea. It's somewhere between 20 and 21 years. So either one of those answers, honestly, I would be okay with. Just make sure you write a sentence that explains your reasoning. Okay, here's one for you to try. Very similar to our last question, but in this case, we are solving for rate instead of time, but everything else is exactly the same. So press pause, try this last question, then press play to see how you did. So again, compounded continuously, I didn't give you the function this time, but hopefully you've dealt with it so much that you know off the top of your head that function that we're going to use. We have an initial investment of 12 grand. It's worth this much at the end, so that's an accumulated amount, 294.95. It's 5 years, so t is 5, so I have r times 5 years. So at what rate did I get? Well, now is where I have to, do the math and get r by itself. So on my last example, I divided each side by the 10 grand, or whatever that number was. I think it was 10. And it was a nice whole number. But if I take 14,294.95 and I divide it by 12 grand, I end up with a very long decimal. So I can choose. I can either write that very long decimal, but don't round it, or I can just leave this guy until the end. So I'm just going to rewrite 94.95 divided by 12 equals e to the 5r. Now I'm going to take the natural log of each side. So the natural log of this hot mess equals the natural log of e to the 5r. This guy goes away, so I just get 5r equals all of this. And yes, it does get a little bit boring and cumbersome to just recopy, but if you're in the equation editor, you can copy and paste just like you do normally. I would divide each side by 5, so my final answer exact is all of this. Not exact, I would take the natural log of that hot mess of stuff that's on the inside. I would divide that answer by 5, and I would get an approximate answer of 0.0349999, etc. I'm looking for what rate did I earn. I'm going to say my rate was approximately 3.5%. So again, I moved it 2 places because rate comes out as a decimal, and that's about 3.5% is the rate. And again, typically on a question like this, it will say round to the nearest tenth of a percent. This is a tenth of a percent. Don't be fooled into taking this, rounding it to 0, because that would be to the nearest tenth. Go ahead and turn it into a percent first, and then round it to the nearest tenth of a percent. So about 3.5%.